Hello, uh, welcome to tutorial 9. As always, we are going to give a few minutes for the people to join us. So let's see if we have more people coming up. So yeah, let's give 5 minutes. In the meantime, please download the dataset merc.csv from Blackboard. This is necessary for today. And just make the preparations in R. I have my R script ready here. It's opening now. So yeah, make sure you have, just wipe all of this. Make sure you have everything ready. Packages, we're going to use the same packages as last week. So no need to install any. However, if you're working on a new computer, make sure that you have these 3 packages installed. Otherwise, they won't work when we call them, so we won't be able to do what we need to do today. So take a minute. Just make sure that that the packages are installed and all of that, and yeah, we'll just wait. I don't know, 2-3 minutes more to see if anyone else joins. Let me actually, in the meantime, let me just fix this. These comments, I'm not sure. They should be here. But other than that, let me just share the links, the code, sorry, in code share, so you can capture the code, the codes, and put them in a fresh R script. So let me just copy all of this, which is going to where we're going to use today, and yep, and paste the link in the chat. So allow me just 1 second. A code share will be there, but let me just put this in the chat for you guys to access the codes, right? Yeah, so we'll just give a second and then we'll start. Remember, as always, set your working directly correctly. Make sure that the path that appears in here is the path where your, let me show you, where your merc.csv file is stored, right? So make sure that's there. And yeah, if you have that there, the package is uninstalled, so you just do a quick search here. The same thing we have been discussed the whole semester. If they are here, no need to install them. So we'll just call them. So I'm actually going to start by loading the packages that we're going to need. So take another minute or so, 2 minutes, and we will start once we have more people here, or just to make sure. Today's tutorial is not going to be too long, to be honest. I'm just going to explain a little bit about the models, but the work itself is not too long. So yeah, you won't take I won't take too much of your time. You still have a little bit of a window to finish your quiz if you haven't. So yeah. And actually, I wanted to start by reminding you that the quiz will be closed very soon. So take your time to do this. I'm under the understanding that is not too long, but it does it does come across as a bit tricky. But unfortunately, I won't be able to help you with this. The word got out that I helped a few guys on the first quizzes, and that's something that's not appreciated by the teachers and all of that. So it's better if I just stay aside. So my apologies to everyone that has like sent me an email and my response has been like completely negative. It's out of my reach, and I hope you guys can understand. But yeah, take your time and work in groups. That always helps. You know, collaborate, and you guys will be able to finish the quiz with success. And this is the last quiz of the semester. So yeah, that's okay, I guess. And by the way, even if the submission for assignment 1 has finished, we still haven't started the marking. So we also a request for you guys to be a little bit patient on that end. We will keep you posted on Blackboard if anything new occurs. But yeah, please allow us, I don't know, a few weeks to get these marks ready. It will be ready before the submission of the next assignment for sure. But yeah, please bear with us in that with that matter. Okay, we're going to continue. Oh, sorry. This is tutorial, week 9, sort of tutorial 8. Due to the mid-semester break and the week before that, we kind of jumped ahead with the enumeration. But yeah, today, technically, let me just fix that up there. Technically, it's tutorial 9, but corresponds to the materials of week 8. Tutorial 8, but corresponds to the material of week 9. But yeah, tutorial 9. Just sorry about that confusion. And we're going to expand on what we learned last week regarding TGARCH and GARCH, GARCH models. But today we're going to expand on those models because those models are limited in two senses. The first is that since the conditional variance is estimated in a square root matter, it needs the coefficients to be non-negative. I just put alpha 1 and beta 1 because GARCH11 is the most, it's the most parsimonious of the models, the simplest of the models, and is the one that's used more widely in the literature. But this condition is difficult to impose, right? The other limitation. Sorry, limitation. The other limitation for the GARCH models is that they cannot account for leverage effects. So what are leverage effects? To put in like short terms or easy terms, it means that a negative shock, so a negative previous shock the day before, so referring to some bad news, has a more severe effect on volatility than a positive shock. So good news. Right? Think of crisis times, right? About 2008, that we had this huge negative shock, volatility was off the roof. Yeah, all of this negativity and just kept adding up and up and up. So increasing the volatility way more and more, right? So we need to account for that phenomena because that phenomena actually exists. Like it comes from human behavior. We get panicked because we received bad news. If our investments in the capital markets are doing bad, we are more prone to make bad decisions. All of this keeps adding up. Whereas we perceive good news as the status quo, right? That things should go well. So if the previous period it's okay, like we get optimistic, but we don't panic, right? So these are two completely natural human responses. And these models have been expanded to account for that. So the first of the two models that we're going to study today is called the threshold GARCH or TGARCH, where we just add a threshold term. So this expression for the conditional variance, except for the middle term, looks just as a GARCH11, right? One log of the arch component, one log of the GARCH component, but we add this threshold term to this model with a dummy variable in between, which will take a value of 1 if the value of the errors, but not in square roots, just the errors, the previous day was lower than 0, meaning that we received some bad news on the period before. And if that's not the case, so if this is equal to 0 or higher than 0, the dummy variable will take a value of 0. This is important because due to the value that this D term takes is how we will reflect the effect of that good news or bad news into the volatility, right? If the period before reflected some good news, so it is like, you know, larger or equal than 0, therefore the dummy variable will be equal to 0. All these terms, sorry, will be equal to 0, right? It's all multiplying, so times 0, all of this goes away. Therefore, the effect of that shock on volatility is just given by alpha 1 in that shock square, right? However, if the time if a period before that reflected some bad news, then this dummy variable will take the value of 1. Therefore, the effect on HT will be transferred by alpha 1 plus lambda times ET minus 1, right? DET minus 1 will be equal to 1. So we simplify that expression. So N, well, the only difference between these effects of transmission is lambda. So if lambda is found to be significantly different than 0, then we conclude on the effect, on the presence, sorry, on the presence of leverage effects. So it's quite I don't want to say straightforward, but it's very intuitive, right? It's a very clever way to find these effects. So yeah, the models will be estimated with a package, with a special package in R that we have been worked so far, the GARCH, GARCH, sorry, package. So we will use it to do this. So let me jump to the questions that we have. Sorry, just trying to locate them. Too much stuff open. Alrighty. Yeah, so we're going to work with the values of the stock price of Merck. We have worked with this data set before. We have observations from January 2nd, 2001 to December 23rd, 2013. This is good because it captured that period during the economic crisis of 2008, which was a period of high uncertainty, like, you know, crisis times. So it's good to observe how that volatility was during those days. We will call the stock prices YT. So we will now estimate models using TGARCH, right? The only difference between the GARCH specification and the TGARCH specification, as we just learned, is given by the presence of the threshold term, which we will program to be like existing or not existing. If there are no like lags of that term, it's just there or it's not there. So we will compute like a lot of models and making the difference if it has the threshold term or if it doesn't. We add both because we want to see if that actually has an effect on the predicted volatilities. And we're going to work with the returns of that stock, log returns of that stock. So we will need to do that as well. So let's all get ready. Let's make the transformations. And actually, I think we can also go ahead and do question A, which is the routine procedure that we have been using the whole semester. Let's just create a set of models to estimate and forecast these volatilities. So let me now jump to RStudio. You guys should have the package in here. I already run them. You can see here on my console that it has attached these packages to my session. Don't mind the red letters. They are not errors. They're just heads up given by the programmers of the packages, but nothing to be worried about there. And we're going to load the data, merck.csv. Please mind the capital M. If you put a lowercase, it's not going to work. So we run that in line 7. Let me just check if, yeah, the numbers are consecutive as well in code share, so that should be the same line for you. So we run line 7, the data gets loaded there, we capture the dates, the date information, which is in the variable date, and please note that it's given in day, month, year format, so we will need to specify that, and it's separated by slashes, so R will be very intuitive in capturing that information into a date variable. In there, we will capture that stock price in Y and actually our variable of interest, which will be the log returns. And as you can see, we have 3,263 variables, values of returns. So we have a very long data set to work with. Let's just give it a quick look at the plot. Here, we just subtract one date out of the plot because, as you can see, date has 3,264 values and R has 63. So they need to be of the same length. So that's why, because log difference of returns, we will lose one value at the beginning, right? But we can see here the variable looks good in terms of mean, but in terms of variability or variance, it's not constant over time. We have some peaks here and some like very deep valleys. So we need to, like as we learned last week, we could be testing for the presence of GARCH effects using the Bruch-Pagan test. But we're not going to do this. It's like very, very likely that when we square the residuals of these and test that, the effects are going to be there. This is not a close call. You can practice this, of course, how to do this, but we're going to skip through this. So more on this in last week's lecture and tutorial. Now, this command to estimate the models is going to be quite complex because we are nesting 5 loops. The lags of AR, the lags of MA, the lags of GARCH, the lags of ARCH, and the presence or not, so 0 and 1, of the threshold term. So that's 5 loops nested in there. Eric actually, we start this index at 0, right? To fill every row of the information criteria matrix that we created, like to store all of these coefficients, all of these values. The number of rows here is given by the possible values of these, like 1 times the other. So times 4 times 2 times 2 times 1 times 2, sorry, actually 0, 1 times 2. So that's the calculation that it's made here. This is equivalent, like we have 4 values that have 4 terms. So that's 4 power 2, and we have 3 terms that have 2 possible values. So that's why it's 2 power 3. You can choose to select that, or you can do the calculation on your own, and yeah, just add it in there to add the necessary rows for that matrix. And we get the names, lags of AR, lags of MA, lags of GARCH, lags of ARCH, whether if it has a threshold value or not, AIC and BIC. So 7 columns by these 7 values. So I'm going to run this, and this submods variable will be given because, or will be specified here because when we are estimating models that, hang on a second, that do have a threshold value, we need to be careful because variables that doesn't have a threshold value will be estimated using the command sgarch or standard GARCH, and models that do have a threshold value will be estimated using GARCH, that command. So we specified that change in here of the model. If threshold is equal to 0, then this index will be equal to 1. So we will use the sgarch command. If threshold is equal to 1, this index will be equal to 2. So we will be using the GARCH model. So that's why we specified there. the main bit here with the loop is that when we don't have any arch or GARCH effects, and if we don't have a threshold term, this exclamation point means not. So threshold is false, so it's 0. We will estimate using the ARMA fit, the RFEMA fit and RFEMA spec. And so those are models that are only AR and like ARMA, but no ARCH, GARCH, anything there, right? So within this package, we need to use these commands to estimate them and capturing the information criteria. Storing the estimates in the ARMA TGARCH EST list that was created to be empty at first, and we will put all the estimates in there. So this is for pure ARMA models. Now for when this condition is not met, so we have ARCH, GARCH effects there, and we need to specify, actually we need to use the GARCH and spec and GARCH fit model, right? But depending on if it has a threshold term or not, we will use SGARCH or GAR GARCH. So that's given by this in the way that I was just explaining. So that's the only difference. None of these, like other than changing your max number of models in here, but I don't see that happening. We use try to see if R can find a way to calculate these models, to estimate the model. If it's taking too long, it will just leave it as not estimatable and move to the next one. So this is a very clever way to avoid those models that will not be estimated. This estimation is quite difficult in terms of computation. So if it's not possible for a combination, it will just leave it as at that and move to the next one. And this message here is going to give us, like, as the loop progresses, which model is being estimated. So we kind of know that R is still working, right? We'll see how that looks like. And with this, we will get a bit of an index of what's the processing time, like how long it took R to calculate all those models. So let me run, actually, I think, let me just check this matrix. Yeah, the call names has been given. So let's estimate from line or run from line 24 to line 84. So highlight everything, Control Enter or press run. Please avoid copying and pasting here in the console because that's very that's very likely that will errors will happen. And you can see here all the combinations have been estimated, only going at ARMA 03. When you see TGARCH here, it means that it's estimating terms with a threshold, models with a threshold term, which is only where it's only GARCH, it's only, you know, the regular arch GARCH effects. So let's just give it a second for it to process all of this, and we'll see what we get. Actually, while it progressed, I'm just going to explain what's next because you guys already know this. I'm selecting the best 20 models in terms of AIC and BIC. All right, we're going to have 128 models. So there's a lot of variety there. And then we're going to find an intersection of these preferred sets. So whatever models are in both lists, that's going to be our preferred set. For your own edification, if that's not possible or you find a different way to create this like intersection set, or no, not intersection, your preferred set, you need to modify this, right? If you run this command as it is, it will always intersect these two. So you will sometimes get a few models, but you can expand here, I don't know, to the top 30. That way, more likely to have models that will intersect. So, you know, many ways that you can go around this. But we will capture all of those AIC and BIC, get the intersection, and as always, get the adequate set with the adequate index. So we will call for the right like slot in this huge list when we call for the estimates. So these commands are pretty much the same as we had so far. So let's, again, it's almost there, I think, ARMA 3.1. But as you can see, the little message here is very useful because you know that R is actually progressing. You don't get like the blank message there. And also you can see here the little stop sign here, the red button, don't press it. But if like in another work or whatever, you notice that R is taking too long and you don't know what's happening, you can always stop the execution, hold the execution, and it will stop on its tracks. I think it's almost over. It's TGARCH. It's just a few combinations of GARCH. When it reaches TGARCH 1.1, that's the end of the loop. It's taking a bit of time calculating that. This estimation is done by maximizing likelihood. So that's always a difficult way. And every software programs these algorithms slightly different. So some programs might be faster than R. R is usually like it usually behaves quite fast. I think Python might be faster at some point, but it's out of scope for just mentioning, throwing it out there, you know. Yeah, it's GARCH 0.1. So yeah, when we reach that TGARCH 1.1, that will be at the end of it. But yeah, as the models, and as you can see, the more items we put in ARMA, the longer this will take, and same for GARCH. So yeah, as you can see, it took 262 seconds to calculate, which is quite significant. Usually it's an instantaneous thing, but yeah, it's all good. Now let's, as I was explaining, let's get the best AIC and and BIC models, the intersection and all of that. The intersection set that we have has, all of them has arch GARCH effects. A few of them are pure ARs, pure MAs, or ARMA models, and very few. Oh no, actually, it looks kind of evenly split, to be honest. The presence of or of thresholds or not. Okay. So yeah, that's our adequate set. We get our indexes because now we need to check the residuals. And as last week's discussion that we had, these residuals cannot be estimated like with the check residuals command. It doesn't like behave well when we have this sort of arch GARCH effects. So we will not trust those results. But what we would do is to create an ACF or sample ACF matrix, empty matrix, with however number of models we have. In this case, we are working with 14 models. That's our adequate set. And we are going to capture the first 10 ACF values for the estimated models according to the index that we have. So we're calling from the estimated list, capturing that the specific variables that the specific combinations that we selected, capturing those residuals and do the ACF of those residuals. And yeah, and just capturing all of that, all those first terms into this matrix. So other than number of models is linked to the index. So yeah, this this code, it's also going to be completely replicable for you. And again, you won't be asked to like do anything like this on your own. So don't worry too much about syntaxes here. So we have our 14 models. We saved the first 5 columns for that specification. So for example, model 1 is an ARMA 00, GARCH 11 without a threshold term. And yeah, it goes all the way to, like, the different combinations. We have a few pairs that have like are the same models but with and without threshold term. So we can also, let me check, I think this one, yeah, this one as well. We have 3 pairs that have with and without threshold term, which will help us to draw some inference of the effect of the presence of those threshold terms. Again, this is not necessary. So we have this this table that I'm displaying here. Yeah, already talked about this. We don't, this is the best that we can do. You can choose to go over 10 lags, but that makes this test harsher. So 10 lags is fine. You can take that as a good reference. And as you can see, none of these values are like even equal to 0.03. The larger is a, oops, sorry, it's a 0.02 something somewhere there. So it seems that these residuals are okay. If we had anything closer to 0.1, so 0.08, 0.09, that would make a cause of concern. So we will grant further analysis of that, but as this like this situation is at the moment, it looks okay. So we will proceed with these effects. Now, next bit, we're going to infer on the existence of leverage effects. So these leverage effects will be tested, like I mentioned before, with that term lambda. So if lambda is found to be significant and positive, right? You guys remember the conditions. Let me go back here real quick. If lambda is found to be larger than 0 and significant, of course, that will confirm the presence of leverage effects. So long story short, if we reject this null hypothesis, then leverage effects are present. So what we're going to do, oh boy, I jumped the gun there. Because first we need to plot estimated volatility. So scratch that. We'll get back to the test in a minute. Sorry about that. For now, we just need to check if there's how the estimated volatilities look like. My apologies for that bit. So we're going to create a little loop in here. Oops, sorry, just until this point. We are creating an empty sort of vector for the title. So it's just creating like a vector with empty values, NA, that's empty values, as many times as we have models. So that's 14 times. And mods here, you can see it in here, it's 14. So it's a vector with 14 empty values. And for each of those empty values, we will just put the title in here. And in here is just capturing what is the how many terms of ARMA, so ARMA, how many terms of threshold, right? So if it has a threshold or not. So if it doesn't, it will show nothing. If it does have it, it will show a T, and the GARCH terms. So we have the GARCH and ARCH terms there. And with paste, you'll put all of that as a string of text, a single string of text. So that's why we put that, and we separate with nothing. So that's the argument in here. And we're going to plot the square root of those residuals, of those errors, right? So to see how that volatility looks like, or how is it estimated. So we are, other than that, we're just calling from the title that we were creating, right? It's a line plot, no X labels, and volatilities in the Y label, but that's just aesthetics. So let's see how these estimated volatilities look like. Oh, it's done. Okay. So you can see, you can scroll through the graphs. They all, Sorry about that. They all look fairly similar, right? Behavior seems to be consistent. Sorry. So yeah, we had some periods of a lot of variability, like around 2005 and around 2008, which is something that we actually observed. We also observed by the end of the sample, variability was a bit low, which is a sign of uh, better times. As you can see, like when we compare models that do have a threshold term and models that don't have a threshold term, it seems that when we don't have a threshold term, the peaks are a little bit steeper, but just a little. So it seems that our models are, let me find another one, this one. Yeah, the peaks are a bit taller when we don't have a threshold term. But overall, those are very minimum changes. This one is quite high. But yeah, overall, this seems to be consistent across specifications. So the differences are not very noticeable. And you can see that also with the scale is quite low still. So yeah. So yeah, this model seems to be robust to specification. Now we're going to move on to the test for leverage effects. So let me recap there a little bit. We are going to test if lambda is equal to 0. So that is an indication that the leverage effects are not present, right? Oops, sorry. If we reject the null hypothesis, then we have evidence that this leverage effect actually exists, right? So we will be interested in seeing if we reject the null hypothesis. So let me jump back to RStudio and let me show you what we're going to do. If you go to this item here, where we have the estimation of the ARMA TGARCH, so it's the large list in here. We have all the 128 models that we estimated, right? You notice that a few of them will be null, means that they couldn't be estimated. R just skipped through them. So that's why we left the try function there, because otherwise the loop would have stopped just after the first model estimated and nothing else. And we don't want that. Now for every model, I wonder which one of these will have a threshold term or not, because we will like to see from the list. Let me try with model 16. So model 16, you press this blue arrow, it will span a little bit on fit. And let's see if we have coefficients. Coefficients are here. Gamma 1, yeah. So this specification had a threshold term. It's called gamma. We call it lambda. So in the materials, lecture slides, and all of that's called lambda. But for the intents and purposes of the package in R, it's called gamma 1. So we're going to extract this coefficient gamma 1, and it also gives us the t-value for gamma 1, which is this very huge number. So we can perform that test to see if gamma 1 lambda it's significant or not. So that's what we do with this. We capture the coefficient and we capture the t-value, and we create, we only do this for the models that actually have a threshold term. So that's why we set this if. For the models that do not have a threshold term, don't do anything. So that's why we don't program our else argument here, nothing like that. Capturing the estimate of lambda, the t-value of lambda, and then putting a small message for us, showing us what model we are estimating, right? Or we are evaluating, and what's the lambda and the t-value. So let me run this little loop here really quickly. And we have 8 models that have a threshold term in our adequate set. Lambda seems to be very similar across, kind of low, but the values are always very large. So we will reject the null hypothesis, these t values will be estimated, will be compared actually to the, let me show you here really quickly, to the values of a one-tailed t table. Like regarding the, like we will need to see the degrees of freedom. We will have 3,000 observations, so it's something close to this. You can see that that like even at the smallest significance, this is like very low. The critical value is 3.2. So anything above 4 pretty much means that we will, for this large data set, right? For other data sets that have like closer to the hundreds, still 4 is a good threshold term for the critical value, but still you need to be careful of that. We rarely work with models that have little, like too little observations, so we will have little critical value, sorry, degrees of freedom. So long story short, t values quite like really high, so we will reject the non-presence of leverage effects at very low significance levels. So we have very strong evidence that leverage effects exist, which is something that we observe in real life, right? Now let me go back to the questions, because we now have to forecast that volatility for 4 days past the end of the sample, right? So for that, we are going to use the command called GARCH put, which will perform this forecast. Forecasting the variability is mode 3. Forecasting the actual values is mode 2, but we are asked to do the forecast of the volatilities. This model is quite, this command is quite simple. However, it will not allow us to select the horizon for that forecast. It will not allow us to do any sort of like customizations to it. We cannot change colors. We cannot put axis names, date titles, anything like that. It's a pretty restrictive command, but it's the best that we have. So let me just clear all of these in here and run this little loop here from lines 154 to 158. And we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 models according to the 14 adequate set. So I would recommend opening the adequate set matrix here, because you will know that the first model corresponds to ARMA 00, GARCH 11, right? So that's the forecasted variability. Don't mind the lines in here, mind these little dots. Those dots are giving us the estimate. I think the estimate is this line of dots in the middle, and we get some uncertainty, some predictive intervals as we have. And these periods in the future are just given by default. So we have 10, but we are asked just to focus on the first 4. So, and as you can see, like this makes sense, because further in the future, you notice how the predictive intervals just get wider and wider and wider. That means that there's a lot of uncertainty, of course, in the future. So the shorter our forecast horizon, the better. So we will just focus on the first 4 periods. Then we go to an MA1 GARCH 11. If you just notice the first 4 days, these predictive intervals, they don't look too different. Maybe the hikes are a little bit weird there, but overall, they look quite similar, right? So yeah, a little bit of variability there, but it's like the change looks too dramatic because of the huge variability after the 5-day point, but from the first 4 days, they don't look too different there. This is these lines here are, I think, some measure of error, something like that. But don't worry about these lines. Just worry about the lines of dots, like these dots that are put in there. Ideally, we would have put like this, like instead of scatter plot, we would put like a line plot, so we will see this predictive interval better. But again, this command won't allow us to check this. So this is the last plot. This is for an AR3 TGARCH11 model, right? We have GARCH, arch terms, and threshold term in there. So they are, you need to be like, if you're asked to do this in an assignment, not sure, it's not possible to give any graph or anything. So you need to be careful of which model is which. So that's why I like wiped all the plots and left only the plots that we are interested in looking at the moment. Let me see. Oh, yeah, the magnitude of the volatilities. You can notice that for the first 4 days, they are rarely above 0.01, right? 4 days is around here. So yeah, they're rarely about 0.1, 0.01. Sorry, they're mostly all the time under below that value. Yeah, 0.11. So I think I wiped that plot. Yeah. So these forecasted volatilities, let me grab these plots again just to compare, are like around this value here, below this value, which is something like below the huge volatility periods of 2008, 2005, which is just something valid. You can, from this, you can gather or you can conclude that you are not expecting the markets to be very volatile in the, I don't know, next week or something like that, right? If you're getting estimates of volatilities like above 0.02, that's a signal of high volatility around. Maybe 0.15 might be, no, 0.2. It's a good threshold for this case. So yeah, that might be a signal that harsher times are coming, but it seems that that's not the case in here. We just wipe these plots because we're going to get more. Now, we're going to move to the second model that we're going to learn today, which is called the GARCHM model. This model will put the GARCH term into the mean estimation. So let me just get all of these messages now. Now the conditional mean, which is this mu, is a function of the conditional variance. So they are conditional variance will also be a function. Sorry, unconditional variance will also be a function there. No, sorry, residuals. But now we are. Sorry, let me start over because I know I made a mess. For the GARCHM mean models, long story short, we have a conditional mean which depends on the conditional variance. The conditional variance it doesn't only affect the errors, it also affects or has an influence on the conditional mean. Right? The structure is given by beta plus delta square root of HT. HT, you know, it's given by arch-GARCH effects, but we are weighting the arch effects by assigning a weight to the previous arch effects. This is programmed by the software by itself, so don't worry about that. So yeah, this is the structure of HT, whatever is inside the square root. The model seems a little bit complex in theory, but it's very useful because we can explore the prediction from the portfolio theory, that it's that the greater the variance of returns, right? The greater the risk, the greater the compensation or the premium that a risk adverse investor will require to hold that asset for in the long term, right? You know, a risk adverse investor will be in panic. So they will require a higher return in order to hold that investment in the future or for the long term. So this model is useful because we want to check if that's something that is present in the day-to-day life, right? In the markets. If we don't find evidence of a time-varying risk premium, that means that risk-averse investors do not respond to risk as they should. So markets are probably in a non-likely situation. Most of the times this will be the case, but with this model we can test for this. We can test if this is actually true. Regarding the structure of the model, I would recommend, I think Eric put a couple of videos in the independent study folder there in Blackboard. So yeah, I would recommend going there and learning a little bit more about the model, like the way that the model is structured. So we're going to, again, construct a set of models to estimate that risk premium, those GARCHM models. So we will start by creating a set of construct a set of models like GARCHM models. So as always, we will start with an empty list to store the coefficient, the estimates, and AIC and BIC in a matrix with the names of that matrix. So I'm going to put all of these. We are nesting only 3 terms because we are keeping GARCH11 constant there. GARCH11, like in practice, are the models that are used the most. So it's something that we can leave there. And that I think, not 100% sure, but I mean, at the very least, this model requires the specification of arch effects. So we cannot have models that do not have arch effects. And yeah, and also GARCH, because HT will be present as well. So it's better off if we don't loop through those specifications without GARCH or GARCH or arch effects. So it's better to leave it constant. You might be willing to maybe go up to 2 arch GARCH effects, but those models are very rare. As you can see in the models that we estimated last week and this week, we rarely go above 1 arch and GARCH effect. So it's better just to keep it constant. Don't go above like the 2 lags of arch and GARCH. It will take forever to estimate, if it's possible to estimate. So for the limitations of our time, it's better just to estimate or leave this constant. So we are just looping through AR, MA, and whether the model is a GARCHM or not, right? So that's what we leave. We put that in here. And we create a little bit of an index here. Sorry, we captured these lags, these terms here, how P, Q, and M are being looped. We capture in order to fill these 3 columns. So that's what we're doing here. And we are estimating models using UGARCH spec and UGARCH fit. Let me just check. Yeah, they don't change if you have a GARCHM model or not. It's just given by this argument here. If you want to add that GARCHM specification, so when this is 0, it will be equal to, like if you put it as false, so it will not be estimated there. It will not be added to the specification. When it's 1, it will be added, so the specification will be there. So this loop, it's a lot easier or a lot shorter than the one that we used before. We will get, again, this little message to see which model has been estimated, and we will get also a measure of the processing time that it will take. So I will run this. It's also, again, it's going to take a few seconds, not going to be immediate, but we can see how it progressed. What else was I going to explain? I think, no, I'm pretty sure that this, again, this command is completely replicable. If you don't change the max number of lags in here, you will not need to change this. This is just 4 times 4 times 2. So that's what we have in here in order to have an IC matrix that has enough rows to store all of these results. It's almost there. Yeah, this is the last of the specifications. Yeah, this was way faster than before. It took only 46 seconds. So that's good. We have our ARMA GARCHM estimates in here in this large list of 32 elements. That's the number of models that we estimated. And we have the AIC ARMA GARCHM, that list of AIC and BIC in there. Now let's filter by the first 20 as before, and we will grab the intersection before them. So in here is good practice, like I was mentioning before, just to check, it's here, that you have enough models. The intersection has 13 models. That's good. That's great. Anything above 6 or 7 would be fine. If you still need more, but you might be tempted to do, in order to keep this model, this code as untouched as possible, you will just expand a little bit, like I was explaining earlier. Maybe more there, more likely that you have more intersections. So yeah, that's that. Grabbing the preferred models and the indices, also something that we always do. And now let's check the residuals. This command is exactly the same as the previous question, in the sense that we are capturing the residuals and doing the ACF of those, capturing the first 10 and looking at them. So I'm going to run this and locate this SACF GARCHM element, which is in here. SACF GARCHM. It has 13 models. All the AR, MA, and whether if it was a GARCHM model or not. When this is 0, for example, let's take this. This is an ARMA 11, GARCH 11, right? This is an ARMA 11, GARCHM 11, right? Because it has that M term in there. Hang on one second. Let me show. Oh yeah, that's the subset of models, and I put the table of residuals in here. Same as last question. None of these is higher than 0.03. Like it's not near close that value, which is good. That means that the residuals seem to be fine. Which is, again, if you had a few numbers there, that would be quite high. So something above, I don't know, 0.05 perhaps, that will warrant further further inspection there. And now for question B, we were asked to check the estimated volatilities and see if they look too different from model to model. So what we're going to do is to plot those volatilities from the estimates. And this is just the way to construct the title that we're going to use as the title of the plot. Again, all of this code will be replicable for you, so don't worry about that. And yeah, so we're doing the square root there. So let me just plot all of this, and we will have all of these models. So we should have 13 graphs in here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, no more than that. 13 models. So you know that for the first, actually we have the titles in here, so you don't need to see this. ARMA 00 GARCH 11, ARMA 00 GARCH M11. So when you have a GARCH M or you don't, in this case, the GARCH N seem to be linked with higher peaks. So it's more sensitive than purely GARCH models. But overall, you can see I'm just going through the plots. They seem to be very similar. We don't have, like we have overall the same behavior. We don't have, I don't know, if some of these plots, these huge spikes will looks like, if they look like something like this, like if you go da 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 da, something like that, then I will say, okay, that looks weird. But overall, they follow the same path here. And yeah, so that's the same conclusion as before. These models seem to be robust to specification, which is okay. So yeah, the only slight difference is that the models with let me find another one that has both. I think this one, yeah. Actually, this one, the peaks are not. The GARCHM, like you can't identify a possible like a behavior that it's consistent across. Sometimes the peaks are higher when you have GARCHM. Sometimes the peaks are lower when you have GARCHM. So I think it's just the variability of the model, uncertainty of the model that will cause this. But yeah, good news. Overall, the behavior looks quite similar, so that's good. And now we're going to check for the existence of that time varying risk premium. So similar test as before, but now we're going to test that delta term. If we fail to reject that null hypothesis, that means that the oops, sorry, this is the opposite. If that delta is equal to 0, so we fail to reject, that's evidence that the time varying risk premium doesn't exist. If we reject, we conclude that that time varying risk premium exists. So that bit on portfolio theory that I explained earlier, it's true. So we find, oh, whoops, sorry, got a little bit ahead of myself. So let me go back to RStudio. So we're going to test that. So for each of these estimates, where is these 32 estimates? Let me just grab one. In here, when you go to, where is fit coefficient? Yeah, here. This GARCHM term in here, this GARCHM term, that's the estimation for delta. And if we go to t-value, GARCHM here, this is the t statistic for that. Let me see if that's the, yeah, this would be the t statistic for that specification. So we are going to call out for those coefficients, or those estimations of delta GARCHM, right? And t values of that for only the models that we chose. And only if they do have a GARCHM terms. So what is it? What is it? No, not TGARCH. GARCHM. So the models that do not have a GARCHM term, so these two, these two, and this one will be excluded from the loop. So let me run this. Yeah, it looked through them and it found that for some of them, the t-value is quite low in comparison to the others, which is in the thousands. But like I mentioned before, like anything, for this sort of sorry, for this sort of level of degrees of freedom, like we have 3,000 or so degrees of freedom. So this number is only going to get lower, but even by the lowest significance levels. So I don't know, probably a threshold of 4 will be fair, a threshold of 3 point something. So it's okay, we will reject anyway. So yeah, we will reject, meaning that we have evidence, substantial evidence of the existence of a time varying risk premium, meaning that investors in this market will require a higher return rate for riskier assets. Now, finally, let's forecast the volatility for 4 trading days past, so similar to what we did before. So we will use GARCH put, and yeah, which equals 3, meaning for the for the volatility. So let's run the last 4 lines in here. And again, 4 days in the futures just up to this point. Something like always lower than 0.011, right? Yep, that's true here. That's true here. Also here, also here. That's all right. Yep. Again, seems to be quite similar from one another. You notice that they do move a little bit, but that's just the rescaling of the axis. But overall, they seem to be very similar values for the first 4 days. Of course, the farther you go in the future, the higher your variability in the forecast. If you want to know, where is the first graph, which model is which, you can always open this adequate set matrix and see. So this one is for ARMA 00 GARCH11. The next one is for ARMA 00 GARCHM11, and so on, all the 13 graphs until the ARMA 32 GARCH11, right? So it's good to know which graph is which. So again, very very consistent throughout specifications, very similar as well. Oh, sorry, and the values again, the predicted volatilities are lower than those experienced during periods of economic turmoil. So we can also conclude that we are not expecting like times to be harsh at least in the foreseeable week, right? The longer we go in the forecast, the more uncertain, the more unsure we are. Now for question 3, we're now asked to do a little bit of a discussion of how we approach forecasting returns and volatilities, assuming a process that is characterized by both a time varying risk premium and a leverage effect. So the main takeaway for this discussion, like the way I see it, is that if we have like this case with the Merck stock price, that it has the presence of both a time varying risk premium and leverage effects, mean that it's very sensitive to volatilities. So, you know, it will be responding to past behaviors in a sensitive way. If past periods have been quite rough, then it will respond accordingly to that, being increasing volatility, which in turns will increase the premium that investors will require. So all of this just keep adding up. All of those, those phenomena will just keep adding up. So uncertain times will become more uncertain. Crises, they just tend to get a lot worse until there is like a drastic intervention, like it happened in 2008, right? Yeah, all of these, like these risk premiums will just put more strain on the markets. So the higher the volatility, the more of a strain that the investors will put on it, will require higher returns, which in turns will call for riskier investments, and just all of that will just keep adding up. So all of this is just like, this is the real world. This is how it works. People will get greedy. People will get scared of hard times. So all of that will be just, you know, piling in there. So most of the processes, most of the sorry, most of the time series in the capital markets, in the money markets as well, like they are in the trading markets, all of that are subject to this. So that's why the trading markets are so uncertain during tough times, because all of these effects will keep adding more and more of a strength to it. So how do we approach forecasting? Of course, with a lot of caution, because volatile times are way difficult to 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 forecast, and easy times we are rarely having any quiet times. Most of the times are like in every decade at least there is a crisis. So forecasting should always be approached like we have done so far, with shorter time horizons, and yeah, knowing that the longest we go in the future, trying to predict the worst we're going to do in that prediction, because it's not reliable. All right, that's all I had for this week. Thank you so much for stopping by. Don't forget, I think you still have a little bit of time before the quiz closes, so use it wisely. But I'm going to hang around if you have any other sort of questions. But as for right now, I cannot help with any quiz questions. And this is the last quiz anyway, so yeah. So sorry about that, but thank you so much for your attendance today. And yeah, I wish you guys all the best. Enjoy your weekend, and I will talk to you next week. Thank you.